Right now, the global energy system is standing at a turning point, where traditional sources like coal, oil, and gas are beginning to show their limits. These systems powered the industrial world for decades, but they are no longer enough to support the rapidly growing demand for clean, efficient, and sustainable power. Nations across the world are now racing to reinvent how energy is produced and distributed. Among them, one country is moving faster than most, investing heavily in technologies that could define the next century of power and reshape the balance of global influence. Across vast regions, enormous investments are being directed toward building a new kind of energy infrastructure. These projects are not small upgrades, they are massive transformations designed to replace outdated systems entirely. From deserts to coastlines, new facilities are rising that harness natural forces more effectively than ever before. Governments, private companies, and research institutions are working together to push the limits of innovation. The scale of funding involved reaches into the billions, signaling a long-term commitment to dominance in the energy sector and a vision that extends far into the future. This shift is not only about generating electricity, it represents a strategic move to control the backbone of modern civilization. Energy powers industries, transportation, communication, and even national security systems. By leading in next-generation energy technologies, a nation can influence global markets and political dynamics. The competition is no longer limited to resources beneath the ground but extends to technological superiority. Whoever masters these new systems will not only meet their own needs but also shape how other countries access and use energy in the years to come. One of the most visible areas of advancement is solar energy. Massive solar farms now stretch across landscapes, capturing sunlight on an unprecedented scale. These installations use advanced panels that are far more efficient than earlier versions, converting more sunlight into usable electricity. Engineers are continuously improving materials and designs to increase output while reducing costs. As a result, solar power is becoming more accessible and reliable. What was once considered a supplementary source is now evolving into a primary pillar of the energy system. Wind energy is also undergoing a dramatic transformation. Towering turbines, both on land and offshore, are being designed to capture stronger and more consistent winds. These modern structures are larger, more durable, and capable of generating significantly higher amounts of electricity. Offshore wind farms, in particular, are expanding rapidly, taking advantage of powerful ocean currents. The combination of improved engineering and strategic placement allows these systems to produce energy around the clock, making them a crucial component of a balanced and resilient energy network. Nuclear technology is another key area receiving renewed attention. Unlike older reactors, new designs focus on safety, efficiency, and reduced waste. Advanced nuclear systems are being developed to provide stable, continuous power without the carbon emissions associated with fossil fuels. Small modular reactors are also gaining popularity, offering flexible solutions that can be deployed in different locations. These innovations aim to address long-standing concerns about nuclear energy while maintaining its ability to generate large amounts of electricity reliably. Among all these advancements, energy storage stands out as one of the most critical breakthroughs. Renewable sources like solar and wind are not always available, making storage essential for maintaining a steady supply. New battery technologies are being developed to store vast amounts of energy for extended periods. These systems can release power when production drops, ensuring stability in the grid. Improvements in battery efficiency, lifespan, and cost are rapidly transforming how energy is managed, making renewables more practical on a large scale. These advanced battery systems are not limited to powering homes or small devices. They are being integrated into entire power grids, supporting cities and industries. Large-scale storage facilities can hold enough energy to supply thousands of households, smoothing out fluctuations in demand and production. This capability reduces reliance on backup fossil fuel plants, further decreasing emissions. As technology continues to improve, energy storage is becoming the backbone of a modern, flexible, and sustainable energy system that can adapt to changing conditions. Beyond current technologies, research into fusion energy represents a bold step toward the future. Fusion aims to replicate the process that powers the sun, generating immense amounts of energy from simple elements. Unlike traditional nuclear reactions, fusion produces minimal waste and carries fewer risks. Scientists and engineers are working tirelessly to overcome the technical challenges involved. If successful, fusion could provide nearly limitless power, fundamentally changing how humanity meets its energy needs and eliminating many of the constraints faced today. The potential impact of fusion energy is enormous. It could reduce dependence on finite resources and significantly lower environmental damage. Industries that require vast amounts of energy could operate more efficiently and sustainably. Developing countries could gain access to affordable power, accelerating global development. While challenges remain, progress is being made steadily. Each breakthrough brings the world closer to a future where energy is abundant, clean, and accessible to all, reshaping economies and improving quality of life on a global scale. Another major innovation lies in the development of smart grids. These advanced systems use digital technology to monitor and manage the flow of electricity in real time. Unlike traditional grids, which operate in a one-directional manner, smart grids allow for two-way communication between producers and consumers. This enables more efficient distribution of energy, reducing waste and improving reliability. By integrating various energy sources, smart grids create a more dynamic and responsive network capable of adapting to changing conditions instantly. Artificial intelligence plays a crucial role in optimizing these smart grids. AI systems analyze vast amounts of data to predict energy demand, identify inefficiencies, and adjust distribution accordingly. This level of automation ensures that energy is delivered where it is needed most, minimizing losses and preventing disruptions. Machine learning algorithms continuously improve performance, making the system smarter over time. The integration of AI transforms energy management into a highly efficient and adaptive process that supports both sustainability and reliability. These technological advancements are also being applied to the development of entire cities powered by clean energy. Urban areas are being designed from the ground up to be self-sufficient, incorporating renewable sources, storage systems, and smart infrastructure. Buildings are equipped with energy-efficient technologies, and transportation systems are powered by electricity. These cities serve as models for sustainable living, demonstrating how modern technology can reduce environmental impact while maintaining high standards of comfort and productivity. In these new urban environments, energy is not just consumed but actively managed and optimized. Residents and businesses can monitor their usage in real time, making informed decisions to reduce waste. Integrated systems ensure that energy is distributed efficiently across all sectors, from residential areas to industrial zones. This holistic approach creates a balanced ecosystem where resources are used responsibly. As more cities adopt these models, the concept of sustainability becomes a practical reality rather than an abstract goal. The scale of these developments is truly massive, involving extensive planning, resources, and coordination. Large infrastructure projects are being executed at a pace rarely seen before. Governments are setting ambitious targets, while private companies are pushing innovation forward. This combination of policy support and technological advancement accelerates progress. The result is a rapidly evolving energy landscape that is transforming how power is generated, stored, and consumed across entire regions. Financial investment plays a critical role in driving this transformation. Billions of dollars are being allocated to research, development, and deployment of new technologies. These investments are not only aimed at immediate gains but also at securing long-term leadership in the global energy market. By funding innovation and scaling production, stakeholders are ensuring that new systems can compete with and eventually replace traditional energy sources. This financial commitment reflects the importance of energy in shaping economic and geopolitical power. As these technologies mature, they begin to influence global markets and supply chains. Countries that adopt advanced energy systems can reduce their dependence on imports and increase their resilience. At the same time, they can export technology and expertise, creating new economic opportunities. This shift changes the dynamics of international relations, where energy independence and technological leadership become key factors in determining influence and stability on the world stage. The transition to future energy systems is not without challenges. Technical limitations, high initial costs, and the need for infrastructure upgrades all present obstacles. However, continuous innovation and collaboration are helping to overcome these barriers. As technologies become more efficient and affordable, adoption rates increase. Public awareness and environmental concerns also drive demand for cleaner energy solutions. Together, these factors create momentum that pushes the transition forward despite the difficulties involved. Ultimately, the direction of global energy is becoming clear. The world is moving toward systems that are cleaner, smarter, and more efficient. The question is no longer whether this transformation will happen, but how quickly it will unfold and who will lead it. Control over future energy technologies means influence over economies, industries, and even geopolitics. As the race continues, the outcome will shape the future of humanity, determining how power is generated, distributed, and controlled for generations to come.